we would like to show that the function u of xy equals the inverse tangent of y over x is harmonic on the complex plane minus the y-axis. On the y-axis, x is equal to 0, and so our function is not defined on the y-axis. But everywhere else that the function is defined, that's the complex plane, take away the y-axis, the function is harmonic, which means that the Laplacian of u is equal to 0, and the Laplacian of u is the second pure partial derivative with respect to x plus the second pure partial derivative with respect to y. So we have to take some second derivatives of this function. We have to recall from Calculus 1 the derivative of the inverse tangent of x is 1 over 1 plus x squared, and a special case of the quotient rule called the reciprocal rule says the derivative of 1 over a function is negative f prime over f squared. So this is just the quotient rule when the numerator is a constant. Well, in particular 1. So these two pieces of information here will help us with the calculation. So let's calculate u sub x. Again, u of xy is equal to the inverse tangent of y over x. So u sub x, the partial derivative of u with respect to x, we have to take the derivative. We're going to need the chain rule. So take the derivative of the outer function, 1 over 1 plus the inside squared. So y over x, quantity squared, and then times the derivative of the inside with respect to x. So this is where the reciprocal rule comes in. The derivative of this fraction with respect to x, the numerator is a constant, so the numerator can just stay. So it's going to be y, and then times the derivative of 1 over x, which is negative 1 over x squared. That's also the reciprocal rule. The derivative of x is 1, and then x squared on the bottom. Now we can multiply these together. Let's rewrite this. Negative y over x squared times 1 plus y squared over x squared. And distribute the x squared, and we get negative y over x squared plus y squared. The x squareds here cancel. Okay, so that's u sub x. So now we need u sub xx. And this is where we really need the reciprocal rule here. The numerator is a constant, so we can just leave the y there. And then the function negative 1 over f of x, or we can think of the negative y as being there. And then we have the function 1 over f of x. So we have negative y times the derivative of 1 over, this will be our f of x. Think of that as f of x. In other words, the y is a constant. So negative f prime, the derivative of this with respect to x, is just 2x, and then divided by f squared, x squared plus y squared, squared. The negatives cancel, and we get the nice fraction 2xy over x squared plus y squared, squared. And now we compute u sub yy, and we will see that u sub yy is the exact same thing except with a minus sign. And so when we add them, we will get 0. Let's do the calculation. Let's leave this one on the board here. There we can see u sub xx. Again, u of xy is the inverse tangent of y over x. Now we want the derivative with respect to y. So u sub y, the derivative of the chain rule, derivative of inverse tangent, 1 over 1 plus the inside squared, and then times the derivative of the inside. This is just y over x. X is a constant. And so we're taking the derivative with respect to y. It's just 1 over x. And now I'd really like to multiply by x squared on the bottom here. So I'm going to rewrite this 1 over x. We'll write it as x over x squared. And now when we multiply these together, we get x over, and distribute the x squared, and we get x squared plus y squared. So there's a nice form for use of y, x over x squared plus y squared. And now use of y, second derivative, pure derivative, not mixed, y. So we have a constant that just sits there, times, and then we have again 1 over f. This is f, and it's a function of y. So we want the derivative of this. Reciprocal rule, it's negative f prime over f squared. F prime, the derivative of this with respect to y, is 2y, and then I missed the minus, negative f prime, and then divide by f squared, x squared plus y squared, quantity squared. So we have negative 2xy over x squared plus y squared, squared. So look at use of xx up here, and use of y down here. They're obviously opposites, and so use of xx plus use of y is equal to 0. In other words, u of xy is harmonic. And this whole computation is valid as long as x does not equal 0, and that means that we're anywhere on the complex plane except for the y-axis. That's where x equals 0. So everywhere else, our function is harmonic.